Piping design codes and standards. For design of piping systems, knowledge of codes and standards, selection of proper material of construction, and to detail out the material specifications is essential. Industry standards are published by professional societies, committees, and trade organizations. Each country has its own codes and standards. On global basis, American national standards are undoubtedly the most widely used, and compliance with those requirements are accepted world over. Next. In US, we have ANSI, that is American National Standard Institute. In Canada, we have SCC, Standard Council of Canada. CEN is present in Europe, that's Committee of European Normalization, and Britain, it's British Standard Institute BSI. AFNOR is there in France, that's Association Francais, and in Germany we have DEN, Deutsches Institut für Normung. In India we have Bureau of Indian Standards, and in Japan we have Japanese Industrial Standards Committee JISC. Now, what is code and what standards? It's code versus standards. One way of looking at the differences between codes and standards is that the code tells you what you need to do, whereas the standard tells you how to do it. That is, it tends to more detailed elaboration, the nuts and bolts of meeting of a code. A code may say that a building must have a fire alarm system, whereas the standard will spell out what kind of system and how it must work. In case of piping, the standards requirements are for design, fabrication, erection, examination tests and inspection. Standard contain design and construction rules and requirements for pipe components, various process services, materials, equipments. Now, compliance to code. Compliance to code is generally mandated by the regulations imposed by regulatory and enforcement agencies, as compliance to standard is normally required by the rules of the applicable code or the purchaser's specification. Now, what are recommended practices? Documents prepared by professional groups or committees indicating good engineering practices but which are optional are the recommended practices. So these are optional, though they have been prepared by the professional groups and committees to ease the work. The US-based American standards referred by piping engineers are mainly the standards by ASME, that's the American Society of Mechanical Engineers, ASTM, American Society for Testing Materials, American Petroleum Institute, API, MSS, that's the Manufacturers Standardization Society, SAE, Society of Automotive Engineers, American Welding Society, NACE, National Association for Corrosion Engineers, and AWA, American Water Works Association, and there are a few more. The code for pressure piping has emerged the same way as the pressure vessel code. The acronym appearing in front of B31 in the title of the code has changed from ASA to ASNSI to ASME. Now, we'll talk about evolution of pressure piping code. In the beginning of 20th century itself, the need for the pressure piping code got started being felt. So to cater to this need, in mid-March 1926, ASME, the sole sponsor, requested the American Standard Association ASA and thus initiated Project B31. So it was on the request of ASME with the sole sponsor that ASA initiated the Project B31. In 1926, a section committee B31 was formed, which, due to wide field involved, comprised some 40 different engineers, societies, industries, government bureaus, institutions, and trade associations. 9 years later, in 1935, the first edition of B31 code got published as the American Tentative Standards Code for Pressure Piping. In 1942, its name got changed to American Standard Code for Pressure Piping ASA B31.1, and it was published till 1955 under the same name, keeping the code current with developments in piping design. It then composed of separate sections for different industries at that time. In 1955, it was then decided to publish as separate documents for various industry sections, beginning with ASA B31.8 1955, Gas Transmission and Distribution Piping Systems, was the first instance. 4 years later, in 1959, the Petroleum Refinery Piping Code ASA B31.3 was first published. This has been taken a reference from B31.3 2012 code section. During the long history of B31 code, various section numbers were assigned for developments. Some of these documents were developed but were not used, as the work was pulled into another section. Some of them were either withdrawn when superseded by other documents. The ASME B31 code is dynamic, and the setting committee worked at keeping the code up to date with the current standard industry practice. Thus, these codes are not a final word but only the latest word, so they are the latest available words. For an overview, a brief list of B31 projects and code is mentioned. ASME B31.1 is for the power piping. ASME B31.2, well, it was meant for fuel gas piping, but it got withdrawn in 1988 and got superseded by ANSI's 223.1 National Fuel Gas Code. ASME B31.3 is for process piping. ASME B31.4 is for pipeline transportation systems for liquid and slurries. ASME B31.5 is for refrigeration piping and heat transfer components. ASME B31.6, well, this was meant for chemical plant piping, but it got never published as a separate document, instead got folded into B31.3 itself. B31.7 is again was meant for nuclear piping, and it was got withdrawn. It got superseded by ASME Boiler and Pressure Vessel Code Section 3. ASME B31.8 is for gas transmission and distribution piping systems. ASME B31.9 is for building services piping. ASME B31.10, well, it was meant for cryogenic piping, but it again never published as a separate document, instead got folded into B31.3 itself. ASME B31.11 for slurry transportation piping. ASME B31.12 for hydrogen piping and pipelines. Now, for the boiler and pressure vessels code, it contains 11 sections altogether, with a 2-section each to power boiler, heating boiler, pressure vessels, and nuclear power plant components. A section each is attributed to material specification, non-destructive examinations, welding, and brazing qualifications. So, 2 sections each for power boiler, heating boiler, pressure vessels, nuclear power plant component, and a section each for material specification, non-destructive examination, welding, and brazing qualifications, making altogether 11 sections. Out of this 11 sections, section 8, that is the rules for the pressure vessel, is important for the process piping engineers. We're talking about ASTM standards, shifting from ASME standards, we'll be moving forward for the ASTM standards. With ASTM standards, the American Society for Testing and Materials, ASTM, develops and publishes voluntary standards on the characteristic performance of material, products, systems, and services. The standard published by the ASTM include test procedures for determining or verifying characteristics such as chemical composition and measuring performances such as tensile strength and bending properties. The standards cover refined materials such as steel and basic products such as machinery and fabricated equipment. The standards are developed by committees drawn from a broad spectrum of professional, industrial, and commercial interests. Many of the standards are made mandatory by the reference in applicable piping codes. A vast majority of the materials of construction for process and utility piping systems used within a plant or are covered by STM specifications. Materials and the testing methods are divided into 15 sections altogether. Each section is divided into various volumes. ASTM covers material of construction for industries other than the petrochemical process facilities, and so many of the 15 volumes are not relevant to the process industry. API standards. The American Petroleum Institute publishes specifications, bulletins, recommended practices, standards, and other publications as an aid to procurement of standardized equipment and materials. The major ones of the API standards are API RP 520. It is meant for recommended practices for sizing, selection, and installation of pressure relief valve devices in refineries particularly. API 560, meant for fire heaters for general refinery services. API 610, meant for centrifugal pumps for petroleum, petrochemical, and natural gas industries. API 612, for petroleum, petrochemical, and natural gas industries, steam turbines, and they are special purpose applications. They are for special purpose applications. API 617 is meant for axial and centrifugal compressor and expander compressors for petroleum, chemical, and gas industry services. API 618 is for reciprocating compressors for petroleum, chemical, and gas industry services. API 650 is welded tanks for storage. API 661 is for air-cooled heat exchangers for general refinery service. Some other common standards referred are American Welding Society, AWS, American Water Works Association, AWA, Manufacturers Standardizing Society, MSS, National Association of Corrosion Engineers, NACE, Society of Automotive Engineers, SAE. Apart from these, there are other national and local standards which needs to be referred as per the requirement. So thank you.